All right, let's take a look at an integration problem involving trigonometric substitution. All right, so in this one you can see that it doesn't look like one of the forms to make our trig substitution. So what we'll have to do is we'll have to get it to look like that. So what we'll need to do with the denominator is that part that's underneath the square root, the x squared minus 6x plus 13, we'll need to complete the square on this. So if we complete the square, we'll rewrite this like this. Okay. Now I would say to you, watch this video the whole way through, because at the end I'm gonna start on another problem. I'm not gonna work the whole thing, but I'm just gonna complete the square on it. It's a little bit different than this one, and there's students tend to mess it up on the completing the square part. So just hang around and I'll show you that at the end too. So remember, to complete the square, we half the middle term, the 6 here, so half that is 3, and then we square it is 9, so we add 9. And since we added 9, we have to come over here and subtract 9, and so that gives us x minus 3 squared plus 4. All right, so what we're going to do here is we will rewrite this as the integral dx over the square root of x minus 3 squared plus 4. All right. So all I did is I replaced this with this. That's all I did. All right. Now, to make it look like one of the forms we need, I'm going to come over here and I'm going to say, let's see, I'll do it over here. Well, let me erase this. I'm going to say let u equal x minus 3, this part here in parentheses, and so du is dx. And so what that's going to do is that is going to give me the integral. So the dx I'm going to replace with du. And then the x minus 3, I'm going to replace with u. So that's u squared plus 4 over, the square root of u squared plus 4. So I've rewritten my integral. All right, so if you remember from the forms you have, if you have the square root of a squared plus x squared, then the substitution that we want to make is x is equal to a times tangent theta. Okay, and you can see this right here is this form here. All right, the only difference is my variable, the x squared, which is my u squared here, that's in front, and the a squared, which that would be 2 squared here. Okay, so I'm going to make my substitution. I'm going to let u equal 2 tangent theta. All right. See, if I write it in this form, this would be what? The square root of 4 plus u squared, which is the square root of 2 squared plus u squared. All right. So you can see u, that's my x, and the 2 is my a. All right. All right, so this tells me that du is 2 secant squared theta d theta. All right, so now let's go ahead and make the substitutions. All right, so this is going to be, now in the place of du, I'm going to put 2 secant squared d theta. So that's 2 secant squared theta d theta over the square root of, and in the place of u, I'm going to put 2 tangent theta. So that's 2 tangent theta, and that's squared, plus 4. And so now we just need to do some simplifying here. So that's 2 secant squared theta over the square root of 4 tangent squared theta plus 4. And I'm going to go ahead and write my d theta out here. I'm going to take it out of the numerator. So then we have the integral 2 secant squared theta over. Now for this one, we're going to go ahead and factor out the 4, and that's tangent squared theta plus 1 d theta. And so this will give me, now look, when I take the square root of 4, that's 2, right? And so that 2 and that 2 cancel. So that's secant squared theta over, now this is going to be the square root. This is going to be the square root of tangent squared plus 1. Well, tangent squared plus 1 is what? Secant squared theta, right? D theta. So let me kind of show you what I did there. This tangent squared plus 1, I rewrote that as secant squared theta. And this square root of 4, okay, because remember I can take the square root of this 4 and then the square root of this. Well, this I rewrote as secant squared theta, and then the square root of 4 is 2, and that 2 and that 2 cancel, so that's why they're gone. All right, and so this is going to give me secant squared theta over secant theta d theta, which is secant theta d theta. Let me write that a little better. All right, so now we need to integrate this thing. All right, so this one's easy. If you remember, this is just one of those basic formulas. This is just what? Natural log absolute value secant theta plus tangent theta plus c. All right. Well, now what we have to do is we have to get this all in terms of x, because that's what our original problem was in. So to do that, this is just like any of the other problems with trig substitution. We're going to do a triangle. So there's theta. Now let's see, what do we know here? Let's see. Well, from this, we know that tangent theta is equal to u over 2, right? And so if I fill this out, tangent theta is u over 2, so that means tangent is opposite over adjacent. And so if I solve this, this is going to be what? U squared plus 4. Okay. Pythagorean theorem. That's a right angle. Now, let's see what I have. Well, I've got to figure out what secant theta is and tangent theta. Well, I know that secant theta is equal to hypotenuse over adjacent. So that's going to be square root u squared plus 4. Let's see, and that's over 2 and that's over 2. And then tangent theta, well, I've got that up here. That's u over 2. So what we can do now is we can write this as natural log, absolute value, secant theta, which is square root u squared plus 4 over 2 plus tangent theta, which is u over 2 plus c. Okay. Now, I still don't have this in terms of x. It's in terms of u. So this, all I have to do is replace the u with what? Well, u is x minus 3. So that's square root x minus 3 squared plus 4 over 2 plus x minus 3 over 2 plus c. Okay? And then this is your answer here. And look, if you wanted to, you could multiply that out. That would be what? X squared minus 6x plus 9 plus 4, which would be x squared minus 6x plus 13. So you could write this instead of this if you wanted to. Okay? But, all right, so that's that problem. But let me show you that other one where you, I'm just going to show the trig substitution part. Let me pause this. Let me erase all this, and I'll work it for you. All right, so let's look at this one. I'm not going to work this problem all the way out. You can see this is in the denominator here. It's similar to the one we just worked. So the thing here is completing the square on this. So we've got 3 minus 2x minus x squared. And I need to complete the square on this. So this, I'm going to go ahead and rewrite it in descending powers. And so remember, you can't complete the square unless you have a 1 in front of your squared term. So I'm going to factor out the 1 here. So that's going to be, well, let's do it like this. It might make more sense to you. So let's go ahead and group it together like this. But here I'll need to factor out a negative 1. So that's going to be negative, and that's going to be x squared plus 2x, and then plus 3. So remember, we got to half this. So if we half it, that's 1. Square it, we get 1. So I add 1. And then if you remember in the first problem, since I added 1, I've got to come out here and subtract 1. Okay? But I'm not subtracting 1 because you see this negative times this 1 here. I'm actually subtracting a negative 1. So this is going to be negative x plus 1 squared plus 4. Okay? What a lot of students will do is they'll just subtract the 1 and they'll forget to multiply this number out here to that. Okay? So it's minus the negative 1. All right, so I hope that helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.